Welcome back. In this video, we will continue to learn about covalent bonding. We'll talk about a concept called electronegativity and how we can use trends in electronegativity and the periodic table to identify whether or not bonds are polar, and then we can rank those bonds based on their polarity. So what is electronegativity? It's a measure of an atom's tendency to pull electron density towards itself when it's in a molecule. So fluorine is the most electronegative element. That means when you have fluorine in a molecule, it will pull the electrons towards it very strongly compared to any other element. What we see is that there is a trend in electronegativity. Electronegativity increases as we go up a group, and it increases as we go across the periodic table from left to right. The reason for this is because the elements higher up in a group are smaller, and they are able to pull the electrons more closely to them because they have a smaller distance between the nucleus that has the positive charges and the electrons. As we go from left to right, those elements are pulling on the exterior valence electrons. And since we're adding in electrons into that outermost shell, and also increasing the number of protons in the nucleus, there's an increased charge in the nucleus that pulls the electrons closer to the nucleus and holds them tightly. And so elements with high electronegativity will pull the electrons towards them. We call that electron density. Elements with low electronegativity, ones that we might call electropositive, very easily give up their electrons to other elements. We can classify different bonds based upon the differences in the electronegativity of the elements that make up that bond. We classify them into three categories. We have nonpolar covalent bonds, polar covalent bonds, and ionic bonds. Nonpolar covalent bonds are bonds in which there is either no difference in electronegativity between the elements, or that the difference is very small. Polar covalent bonds have a moderate difference in electronegativity between the elements, whereas ionic bonds have a very high difference in electronegativity between the two elements involved in the bonds. You do not need to know the cutoff values for nonpolar to polar or polar to ionic bonds, but rather you're expected to be able to rank bonds based on their polarity differences by thinking about the periodic trend of electronegativity. So let's do a practice problem here. In which compound does chlorine carry the largest partial negative charge? So how do we do this? What we want to do is evaluate in each case the electronegativity differences between chlorine and the element that it's bound to. We saw that the trend in electronegativity is that electronegativity of an element increases as we go from left to right and increases as we go up a column. So when you look at the location of fluorine and chlorine, bromine and iodine relative to each other, you can see that they're all in the same group. Therefore, the only thing we need to consider is which one is higher up on the periodic table. So if we draw the relative positions of these elements, we see fluorine at the top of the group, then chlorine, then bromine, and then iodine. So the chlorine-fluorine bond has fluorine being more electronegative, which puts a positive charge on the chlorine. For now, let's ignore the values down here and just think about it in terms of which one is more or less electronegative. For the chlorine-chlorine bond, those have the same electronegativity values, therefore there's no difference in electronegativity, so it's neither positive nor negatively charged. In the chlorine-bromine bond, chlorine is more electronegative, so it has a negative partial charge on it. And then chlorine and iodine, the chlorine is also more electronegative, and so it contains a partial negative charge as well. So we want to know which one has the largest partial negative charge. Well, we can easily eliminate these two choices because they don't put negative charges on the chlorine. For these other ones, if you knew the values, you could calculate and find the actual partial negative charge on each element. However, it's more important that you be able to recognize that because we're looking at a chlorine-bromine and a chlorine-iodine bond, that the bromine's electronegativity must be closer to chlorine than the iodine's electronegativity is to chlorine. Therefore, there's a larger gap in electronegativities between chlorine and iodine. And therefore, that molecule has the largest partial negative charge on the chlorine. That's it for this video. Thanks for watching. Have a great day.